Alright, we are back. This is Techmath1. We're looking at chapter 6. And today we're going to cover 6.5. So that is on temperature. It's in the blue book, page 251. Is where it starts. We're actually going to do our first problem off of 252, number 34. So we want to change if F is equal to 122 degrees Fahrenheit, how many degrees Celsius is that? And if F is equal to 41 degrees Fahrenheit, how many degrees Celsius is that? And so you're going to actually put this into a formula to convert. We have Celsius. Well, they actually have three different formulas on the page before. I think this is the easiest out of the three. On number 34, they've got Celsius is equal to 5F minus 160, and then all over 9. And so it's not just a different, it isn't like you can just add 30 or subtract 20 or whatever to convert from Celsius to degrees. It's actually a different scale. So it would be comparable to somebody who doesn't understand our money might just look at quarters the same as nickels. You'd say, oh, here, I'll give you 3 nickels and you give me 3 quarters and we're even. But we know that's not the same. You know, 1/4 of a dollar and 1/20th of a dollar. That's sort of what's going on here. There's a different scale with more lines on it, basically, for Celsius. So we put that in 5 times 122 minus 160 all over 9. Now, you might have seen this one already, the 5/9 times Fahrenheit minus 32. That might make a little more sense because the 32 degrees is freezing and on Celsius it's 0. But this is just this a little bit easier to substitute. You know, you're not doing the distributed property then the both. We're just carrying out this. So we take 5 times 122 times 122, and then minus 160. So that's 450 over 9. Divide that by 9. That is 50 degrees Celsius. 50 degrees Celsius. So if it's 122 degrees outside and you're cooking eggs on the sidewalk, that would be 50 degrees Celsius. All right. How about 41 degrees? Well, same formula. We're just going to put in a 41 for F. So 5 times 41 minus 160 is 45. Divided by 9, that is 5 degrees Celsius. Which makes sense. It's pretty close to freezing. It's 9 degrees above freezing. 32 degrees is freezing on Fahrenheit. And so that's only 5 degrees above freezing on the Celsius scale. All right. Okay. Then let's jump to number 40. They're going from Kelvin to Celsius to Fahrenheit. So let's take a look at that. Kelvin is a different scale. Scientists use, I think in like extreme cases when they're talking about Kelvin. So let's look at, we're looking at number 40. 253 degrees Kelvin is how many degrees Celsius, and then how many degrees Fahrenheit is that. So they want those two things. So Kelvin is just converting degrees. Kelvin uses the same scale as Celsius. So it's just whatever Kelvin is minus 273 degrees. So we're going to do this. We're just going to say Celsius is equal to Kelvin minus 273. So that is just bumped up, 273 degrees. So if it was 253 degrees Kelvin minus 273, 253 minus 273 is negative 20. So we're talking negative 20 degrees Celsius. And then if we want to convert it back to Fahrenheit, that would be 9 over 5 plus 32. So we take that negative 20, put it in for C. That's negative 180 over 5 plus 32. So just conversions, just plug and chug. You're taking things and put them into formulas. Negative 36 plus 32. You can probably do that one in your head, right? Negative 4 degrees. So yeah, that fits. If it's 20 degrees below freezing for Celsius, remember it's a different scale, but 32 degrees is freezing for Fahrenheit, and that's well below 32 degrees, right? It's 36 degrees lower, so there we are. Let's take a look at 6.6, decimal number system, and powers of 10. So I already kind of did this when I explained the metric system already. So decimals, we did the metric system and it was base 10. And so, if you go to the right, it's smaller. If you go to the left, it's larger. And so if you take a look on 255, they have millions, 100,000s, 10,000s, thousands, hundreds, tens, ones, decimal points, tenths, hundreds, thousands, 10,000s, 100,000s, millions. And so nothing really too big and exciting here. We'll go through 6.6 pretty quick. Because again, I think this is very much review for everybody in this class. So we're looking, let's just look at 47. If we have 10 to the 12th power, write the name for each place. Well, if there's that many zeros, 12 zeros, that's actually trillions. And if it's 10 to the negative 9, that would be billions, because it's negative 9, so that's smaller. So look, if that's 1 over 10 to the 9th, or 1 over, and that's a 1 with 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Because every time you throw a 10 on there, that's 10 times 10 times 10 times 10, it just adds a 0, add a 0, add a 0, add a 0. So 1 times 10, 9 tens in a row would be 1 billionth. So billions. All right. Okay, so then we got 48. Billions would be what? 10 to what power? That would be 10 to the 9th power would be billions, right? and then trillionths. Trillionths. That means they want it on the bottom. So trillions would be 10 to the 12th. But if we want it on the bottom, like to move down to the bottom, remember negative exponents, move it down to the bottom. So just 10 to the negative 12th. All right? Then again, they talk about metric prefixes. We talked about those already. Kilo, hecto, deca, deci, centi, milli, with the base unit in the middle. They actually go a little farther. And some of you, I know in some of your careers are going to use these different, out of the book here, that's page 257 if you're following along. But they've got tera, giga, mega, kilo, hecto, deca, deci, centi, milli, so that the middle 6 we know. And then micro, nano, and pico is trillionths. All right? So those are interesting prefixes that you use here. That's a 6.7 already. So let's jump to just one problem off of there, 57. Teragrams and gigameters and micrograms. Electricians told me that they use microfarads all the time. And nanoseconds. Computer programmers have come back and told me nanoseconds is a thing with computing. Okay. And now, right, with all the gaming and everything, computers have a terabyte. That's so I can put a number to that. That tera is 10 to the 12th power. That's trillions. It's a trillion bytes. Wow, terabytes. All right. So this one, they just want the shorthand for it. So this is a big old capital T and then a G. TG. Giga is actually the just a big old G. Gigameters. Micro, they borrow from the Greek letter mu, and then grams. So micro is the mu symbol. And then nanosecond, that's just a small n. And then second is SEC, so nanosecond. So those would be the shorthands. In the past, I was saying remember those, memorize those, but you get to use it's open notes. And actually, I think there was on the blue sheet, the reference sheet that you could use on the test anyway, that even before the online stuff, you got to use a formula sheet. So it's a place you can find it readily, so you know to look for it. All right, let's look at 6-8. 6-8 is transforming. Okay, so here we go again. And again, we did these before. 66, 9.7 meters and 2 kilometers. It's just we didn't have the biggies there. So 14.6 microseconds is how many nanoseconds, and 0.58 teragrams. What's the big M again? The big M is megagrams. I mean, teragrams and megagram. And then 2.3 millimeters. So that's one that we're into. Nanometers. That's going to be a lot. That's going to be a big number. All right, so look, you go back to the page before it, and we've got the conversions right there. And you just look for the letters right there, right above the boxes. So that would be probably a good page to earmark for the test, like 259. All right, so 9.7 megameters is how many kilometers? Well, let's see. The little boxes are just unnamed, but we have to count them. So from the big M to kilo is actually 1, 2, 3 places to the right. We just go 1, 2, 3 places to the right. That's 9,700. All right. 14.6, and what's mu again? Mu was micro, so microseconds is how many nanoseconds. So you're going from micro to nano, so that's 1, 2, 3 places to the right. So 1, 2, 3 places to the right, 14,600. And then we're going 0.58 teragrams, that's way far to the left there, teragrams, to mega, that's going to be 1, 2, 3, 4, 5, 6 places to the right. So 1, 2, 3, 4, 5, 6. That's a 58 with 1, 2, 3, 4 zeros. So 580,000 megagrams. All righty. And then the last one, 2.3 millimeters. We know what those are. So you start there. And they want to go to nano. So that's 1, 2, 3, 4, 5, 6 places to the right again. 1, 2, 3, 4, 5, 6. So that is going to be a 2, a 3, and then 1, 2, 3, 4, 5 zeros added on. Whew. 2,300,000. That's 580,000, 14,000, 9,700. All right. So 2.3 million nanometers. All right, awesome. So that is 6-8 in a nutshell.